going to be covering chapter 12, and then we're going to be covering about half of chapter 13 as well. So it will be, it'll be about the same length as our normal lectures. But it'll be good. So we're going over the cardiovascular system today. We'll go ahead and hit that. And hopefully, I don't know why this chat is not coming up anymore. No, okay, hold on, give me 1 second here while I figure this out. There it is, okay. Oops, oh, that's not what I wanted. Okay, cool. All right, I don't know why it's not showing up, but apologies for that. So if you guys have any questions, just hit the unmute button at the bottom of your screen, unmute yourself, and then just ask me whatever that question is. So feel free to stop me at any time. Okay, so today we are going to be going over the cardiovascular system, and we're going to be talking about blood specifically first, and then we're going to be looking at the heart. Okay. So what's kind of interesting about the cardiovascular system is it kind of essentially works like a system of roadways. Actually, go ahead and just kind of chime in here. If you think about the cardiovascular system, what components are we normally thinking about?
Atrium and ventricles.
So are we looking at the atrium and the ventricles, so the parts of the heart? Okay, what else?
Yeah.
The blood vessels.
The blood vessels, and then what else?
Capillary
Veins.
Capillaries and veins, Okay. And then one other component here?
Arteries.
Blood.
The blood, right. So the blood. So when we think about the cardiovascular system, that's not. So when we think about the cardiovascular system, it essentially acts as a system of roadways. So you can kind of think about the blood vessels as being the roads, the blood as being the kind of the cars on the road, and then the heart is essentially the gas that kind of allows the cars to be able to go. Okay. So what's going to be happening here is the heart is going to be contracting, and as it contracts, it's going to be pushing blood from one place to another. Okay. So we're going to be looking at that first. And so here, what we're going to be doing is we are going to be looking at the blood. We're going to be looking at the cardiovascular system, and we're going to be looking at how all the different cells within the blood are going to be working. Okay. We're going to be looking at the different types of blood cells, red blood cells, white blood cells, and then we're also going to take a look at platelets, and we're going to look at how all the different, or how they're going to be formed and what all of their abilities are going to be going forward here. Okay. All right, so here we go. All right, so when we look at the heart the cardiovascular system is going to be made up of, like we talked about, the blood, the heart, and then the blood vessels. So those are going to be the roadways that allow the blood to be able to move from point A to point B. Okay, so as we study the heart is going to be studied through the science of hematology, which looks at the blood, all the blood vessels, and all the blood-forming tissues, and any disorders associated with blood vessels. Okay, so blood is going to have multiple different roles. The first role is it's going to be able to transport various substances from point A to point B, and we'll look at each of these roles in a little bit more detail as we go forward here. The second role is it's going to help with regulating several life processes and allowing different things to be able to work within the body without falling apart. And then the third role is it's going to be able to protect the body from various diseases and protect the body in other ways as well. Okay. And again, we'll look at all these in a little bit more detail as we go forward here. Okay. So when we're looking at the blood is going to have a pH of about 7.4, and that pH is going to be very, very important, because if that pH even goes just high enough to even just a 7.5 or lower to a 7.3, just that 0.1 difference is significant enough to cause some like total organ failure throughout the body, and that can cause the body to shut down and ultimately lead to death. So that pH of a 7.4 is incredibly, incredibly important. So the blood is going to have lots of different types of buffer systems, which you'll learn about when you take physiology, that allow the blood to be able to maintain its pH regardless of the things that you're eating and the things that you're drinking, which would normally alter your pH. And so this is going to have a way of stabilizing its pH at 7.4. Okay. In addition to that, it's also going to have a temperature of about 38 degrees Celsius, which is going to contribute to your normal body temperature, which is about 37 degrees Celsius or 98.6 degrees Fahrenheit. In males, blood volume is essentially going to be about 5 to 6 liters, and in females is going to be about 4 to 5 liters. The difference between the two just has to do with the differences in body size between males and females, but that's really the only real difference in terms of blood volume. And then one kind of misconception about the blood is that when the blood is oxygenated with oxygen, or saturated with oxygen, it's going to have lots of oxygen within it. It's going to have a more red color. And then a misconception that people usually kind of get is that when blood is deoxygenated, it tends to be blue. Okay, that's not really true. It typically is going to be more of a darker red color. And then in some cases it can be purple, but it's usually never blue, but it's often depicted as blue when we're looking at deoxygenated blood. Okay. So kind of going forward here to look at some of the functions. The first function, and probably the most important function of the blood, is transportation. So one of the things that we really need to be able to transport across our body systems is going to be oxygen. Okay? And so oxygen is a gas that we obviously are going to be getting from the atmosphere, and we're going to be taking that into our lungs. Once it gets into our lungs, then the next job of our blood is going to be to pick up that oxygen and then transport it to wherever it needs to go throughout the body. Okay? Now, as the blood delivers that oxygen to different places, it's also going to be able to pick up carbon dioxide from those same body cells, deliver those back to the lungs, and then from there we're able to then exhale that carbon dioxide. Okay. So oxygen and carbon dioxide transportation is going to be one of the most important functions of the heart, or sorry, of the blood. Okay. The next things that are going to be able to be transported are going to be nutrients and waste as well. So when we take in lots of different foods, if we're hungry, we eat lots of our Cinnamon Toast Crunch in the morning, right? We're going to be taking lots of those sugars that we're eating in our cereal, and that sugar is going to get deposited into the blood, and then from there the blood can then transport that sugar to wherever it needs to go, okay? To the cells that are in need of sugar, okay? And then any cells that have extra sugar are going to be able to form some glycogen as well. Okay? Then again, at the same time as we start to produce or start to deliver nutrients, those cells are also going to be producing lots of waste. And so what we're going to be doing is we're going to be taking that waste, dropping that off into the blood, and then again, you can deliver those wastes to different places in the body, either the lungs or the kidneys or the skin or various other places as well. Okay, and then heat is another thing that can be transported as well. So that heat, because the water inside the blood is able to absorb heat, it's going to be able to transport heat throughout the body as well. And the last thing that's going to be important here is that hormones are also going to be picked up in the blood as well. Okay, so hormones like testosterone, progesterone, cortisol, which is the stress hormone, various types of hormones are going to be transported directly through the blood. Okay, and once they get dropped off into the blood, they're eventually going to reach a certain cell that's going to have a receptor for that particular hormone, and then the hormone can then form its action in that way. So transportation is going to be the major role inside the body. Okay. The second role is regulation. So like we talked about, blood has the ability to regulate its own pH. And so that's going to be important to make sure that, obviously the blood is working with the way it's supposed to, but also make sure that all the organs which are going to be receiving that blood are also going to be able to work the way they need to work as well. Okay. Temperature is also going to be a way that we can, or a thing that we can regulate, again, just by absorbing different heat using the water inside your blood plasma. And then the osmotic concentrations, so your solute concentrations, your salt, water, and any different substance that's dissolved inside the blood, those are all going to be regulated by the blood as well. Okay. And then the last function is going to be protection. Okay. So protection is going to be important because obviously we're going to be going through different things in our body. We are going to be getting exposed to various types of bacteria. Okay, so when we get exposed to different bacteria and lots of other pathogens, we're going to have specific cells inside of our blood called the white blood cells, and they're going to be able to tackle a lot of those pathogens that have invaded our body. Okay? And so they're going to have various different types of defense mechanisms to help ensure that we're able to be protected against various types of pathogens like we talked about. Okay. And then the last function is more kind of like a physical function where it's going to help with blood clotting. Okay. So if I get upset with my brother and I'm really pissed off at him, I might, say, what, I'm really frustrated with you, and maybe I scratch him or cut him or whatever it may be. He's going to start to bleed. Now, when he starts to bleed, obviously he's not going to start to just continuously just bleed and bleed and bleed and bleed until he eventually bleeds out and dies, right? What's going to end up happening is the blood is going to be able to clot and eventually form a scab, and then prevent any further blood loss. And so it's going to be able to protect us from essentially hemorrhaging out. Okay. Okay, so when we look at blood, blood is going to be made up of blood plasma as well as formed elements. So there's going to be different components of blood. So if you've ever gone to get your blood drawn, you're going to see that your blood is going to end up filling a vial. Okay, it's going to fill out the entire vial. What hematologists will do is when they're looking for someone who's got a blood disease, what they'll do is they'll take that vial and they'll spin it in a centrifuge, and it spins it extremely fast and starts to separate everything inside of the blood out. Okay. And so we end up with kind of two layers. Okay. We end up with this top layer, which is more of a yellowish color, and so that is the blood plasma itself. Okay. So that's the blood plasma. So that's going to be the watery kind of extracellular matrix that makes up blood. Okay. So if you remember, blood is a type of connective tissue where there's going to be lots of extracellular matrix. In this case, that ECM is going to be the blood plasma. Okay. The second thing that we're going to be seeing are these formed elements, which are the red blood cells. I think I'm seeing an error, so I think this thing might kick me out in a second. So hopefully there's not any issues, but if not, I'll reopen this meeting in a bit. So if this thing cuts out, I'm sorry. I'm going to reopen this Zoom meeting so that we can jump back in here. So I'll just kind of continue, and if it kicks us out, we'll see what happens. Okay, so that's the blood plasma. The second component are the formed elements. And so the formed elements are the cell fragments and cells. Okay, so those will be our red blood cells, our white blood cells, and our platelets. And so that's going to make up the bottom layer of